Hi guys, welcome to your screencast on strength. So we have looked at types of strength, factors that affect strength, methods of evaluating strength, as well as training to develop strength. So the last little bit we need to look at now is physiological adaptations from strength training. We need to be looking at muscle and connective tissues, neural changes, as well as metabolic changes. So first of all, these are the adaptations that take place as I've just described. We are going to be going through neural adaptations, muscular and metabolic adaptations. So to start with, we'll look at neural adaptations. So we have got structural adaptations and then a functional effect. Please make sure you've got key questions for each one of these so we go through them. First of all, the structural adaptation that takes place. The actual physiological adaptation that takes place is an increased synchronization and recruitment of type 2B motor units and muscle fiber types. The overall effect this has is an increased force of muscular contraction. Okay, we get a decreased inhibition of the stretch reflex. This means that we can actually stretch further, so essentially we are going to be generating more power in that recoil. So this means getting increased force of contraction from the agonist muscle. For example, tricep acts as a recoil for biceps during the bicep curl. The overall effect is increased speed, increased strength, and increased power output. So there are neural adaptations. Please make sure you have questions for each one and then the overall as well. We've got muscular adaptations that take place due to strength training. First of all, the structural adaptation that takes place is muscle hyperplasia, and we also have muscle hypertrophy, i.e. our cross-sectional area increases. We know how that affects our strength due to factors that affect our strength. The functional effect of these two are increased force of contraction. Maximum and explosive training will increase size of type 2B muscle fiber types. Strength endurance training will increase size of our fast oxidative glycolytic fibers. Overall effect, increased muscle mass leading to increased speed, increased strength, and increased power output. Finally, again, can have questions on muscle hyperplasia and muscle hypertrophy as well, please. So finally, metabolic adaptations that take place, we have got increased glycogen stores and ATP and phosphocreatine. This means you've got an increased capacity for very high intensity energy production, increased energy for speed and power activities such as long jump, triple jump, 100-meter sprint. Increased enzyme activity, okay, so increased activity of specific anaerobic enzymes so that we break down anaerobic energy sources more efficiently, so increased efficiency of anaerobic energy production, increased activity of ATPase, creatine kinase and glycolytic enzymes. This helps to reduce the onset of fatigue. Increased tolerance of lactic acid buffering capacity, which means you've got an increased tolerance and removal of lactic acid, so this delays obla, increased anaerobic threshold, increased threshold of the anaerobic system, which means you've got a delayed obla, and then overall this effect of the metabolic adaptations is increased anaerobic fuel stores and energy production. Fatigue is delayed due to increased anaerobic threshold and delayed obla. This all leads to an increase in intensity and duration of performance. Okay, so there are your notes. Please make sure you've got questions for each individual sections for me and you've got the functional effect written down as well. Thank you.